Exciting day. This word at the top of the page, you may or may not have heard the word before. Stoichiometry, a word that strikes fear into the heart of many chemistry students, but not my chemistry students, because we're going to see this is actually a pretty simple idea. There's nothing difficult about it. Involves a little bit of mathematics, but we're talking simple mathematics. Really, if you remember at the beginning of the course, I said that one of the things that's crucial that you're able to do for this class is unit conversions. And so if you can do a unit conversion, you're going to be great. In other words, converting from inches to feet, converting from hours to seconds, things like that. A lot of what we do, if it ever clicks with you that it's just unit conversions, you're going to be like, this is super simple. So we're going to learn a new unit today, and we're going to see how we convert with that unit. And that's kind of the basis behind what we're talking about with stoichiometry. But let's begin with calcium. All right, you see it over in the corner of the screen. I guess in your corner of the screen, it's maybe over here. And when you're looking at calcium, this is just a copy from the periodic table in the front of our book. Remember the things that the numbers mean. The number at the top, the 20, is the atomic number, and that means that's how many protons this atom has, one calcium atom has. But the number at the bottom, if you remember, is the atomic mass, right? And that atomic mass is in atomic mass units. Now, when we learned about atomic mass units, we said we used atomic mass units because atoms and molecules are extremely small, right? So to use a unit like grams, it would be scientific notation would 10 to the power of a negative number, and it would be kind of ugly to work with. But one of the things we said is that 1 AMU, when we first learned about the atomic mass unit, is that 1 AMU is equal to 1.66 times 10 to the negative 24 grams, right? So that was the value that we used to convert from atomic mass units to grams. And so if we think about that for a second, what that means is if I wanted to know what the mass was of a single calcium atom in grams, I would say, well, a single calcium atom has an atomic mass of 4.08 AMU. And so using this conversion relationship right here, I would multiply this times 1.66 times 10 to the negative 24 grams over 1 AMU, right? When I do this, my AMU units cancel out, and I would get a value of 6.653 times 10 to the negative 23 grams. All right, so that's what a single atom of calcium would have a mass of in grams. All right. Now I want to try something else, and this is going to be the concept behind this new unit that I was telling you that we were going to learn. What if I'm thinking about this value, 4.08, which is the atomic mass of a single atom? What if I wanted to know what would be the mass of 4.08 grams? Or not the mass, I'm sorry. How many atoms would be in 4.08 grams of calcium? So again, I picked this number here because it happens to be the same numerical value as that, right? Again, this numerical value up here we know that to mean the atomic mass in AMUs of a single calcium atom, but I want to know how many calcium atoms are in that many grams, all right? Well, if we do the math with that, how would we do that? Well, we would take the 4.08 grams, and we would divide it by what the mass is of a single calcium atom, right? So we would do this math here. And so if it turns out if we take that value and divide it by 6.653 times 10 to the negative 23, which is the mass of a single atom, we see that there are 6.02 times 10 to the 23 atoms in 4.08 grams of calcium. All right? This is an important number. 6.02 times 10 to the 23. That value is what we call a mole, all right? You only know mole as the furry creature that crawls through the ground. My dog back home used to bring me moles that she had dug up as prizes. So that's not the kind of mole we're talking about, right? In chemistry, a mole refers to 6.02 times 10 to the 23 of something. Now, why do I say of something? Because a mole is a value like a dozen, right? What is a dozen? Well, we say a dozen, 1 dozen, right, equals 12. 12 what? Well, 12 of anything, right? If I have a dozen eggs, then I have 12 eggs. But I could also have a dozen brownies, right? I don't know why brownies keep coming up in chemistry, but they do. So a dozen brownies, I have 12 brownies, right? It's just it's a word that we use that we know means 12, right? If I get a dozen donuts, I have 12 donuts. Well, same way, if I have 1 mole of anything, if I have a mole of atoms, it's going to be 6.02 times 10 to the 23 atoms. But I could also have a mole of molecules, 6.02 times 10 to the 23 molecules. I could have a mole of, I'm looking here in front of me, I have safety goggles in my office, right? I could have a mole of safety goggles. That would mean that I had 6.02 times 10 to the 23 safety goggles. I would never have to buy safety goggles again, right? I'm set for, not just for life, but for many lives. So 6.02 times 10 to the 23 is what 1 mole is equal to. That's our new unit. That's an important unit. We're going to use that for the rest of the course. So it's critical that we understand what a mole means. Now this number 6.02 times 10 to the 23, I do want you to remember that. We're not going to use that value as often as we just use this idea, this concept of a mole. But it's important that we always remember, if we wanted to know how many atoms we were talking about or how many moles we were talking about, if we said, for example, we have 8 moles, we could figure that out, right? By the way, just for fun, I thought you would like to know, if you were taking this course during the school year, on October the 23rd, at 6:02 a.m., Mole Day would begin. And it would last until October the 23rd, 6:02. I don't know why I didn't put another dot there. 6:02 p.m., right? So from 6:02 p.m., where do we get that? Well, that comes from this value in the front of our mole value. On October, which is the 10th month, the 23rd day, we celebrate Mole Day, okay? So, now that you know about this, October the 23rd of this year, if you want to send me a picture of you in a mole costume, that would be great. Actually, I can't find a mole costume anywhere because I would love to wear a mole costume on Mole Day to school, but I can't find it. So if you happen to find a mole costume, you let me know. All right. So anyway, our big takeaway is 6.02 times 10 to the 23 equals 1 mole. We need to make sure that we know that. You need to memorize that. It's important that you know that value. All right. So let's actually use that value now. So let's see. Oops, I don't know why that popped up. All right, so how are we going to put that value to use? Well, the first thing that I want us to realize is what we just calculated, right? When we calculated 40.08 grams of calcium atoms, we found out that that equals 6.02 times 10 to the 23 atoms, right? That many atoms has a mass of 40.08 grams. All right, but what did we say 6.02 times 10 to the 23 was? Well, that's the number of moles. So what we're going to say is that 4.08 grams of calcium is equal to 1 mole of calcium. All right, if we have a mole of calcium atoms, it's going to equal 40.08 grams. And so that means that this number, now the number that's underneath the atomic symbol or the chemical symbol for the substance on the periodic table, not only refers to the mass of a single atom, in AMUs, it not only refers to that, but that number underneath has a second meaning, and it is the number of grams of 1 mole of that atom, right? In other words, if we had 1 mole of calcium atoms, or 6.02 times 10 to the 23 calcium atoms, it would have a mass of 40.08 grams, okay? So 2 meanings for that value. And how are we going to use that? All right, let's actually put that to use. And in order to do that, I want to go to example 7.1 in the book. So if you will turn there, what does example 7.1 say? Well, it's in that particular problem, we don't have calcium. Instead, we have a molecule, a single molecule of glucose, which has a, let me erase this. Let me remove this calcium. Oh, I can't get it out of here. I was afraid that was going to happen. For some reason, this thing does not like me trying to grab stuff once I start drawing. So that's okay. That's all right. We'll just make do. So we'll leave that calcium guy on there. But let's look at the problem. And the problem says, what if you have C6H12O6, and we want to just trying to make that H look a little better. There we go. We want to find out what the mass of a single molecule of glucose is. All right, how would we figure that out? Well, it didn't tell us what unit it wanted the mass in, right? It didn't ask for grams. So the easiest way for us to find the mass of this molecule is to leave it in AMUs. All right. You know what? Let me see if this will work. Cool, that does work. Let me remove it that way, because again, what are we looking at? We're looking at C6H12O6. All right, and I wanted to do that because if let's see, let me go over here to this. I've taken a copy of the periodic table that's in the front of the book, and we're going to copy that right here just so we can look at it. And let me try to position this a little bit better. Let's see. How am I going to do that? Let's move it that way. We'll move this guy this way. All right, cool. Here we go. And again, we're interested in C6H12O6. All right. So we're wanting to find out what the mass is of C6H12O6. That's a single molecule of that. So what we're going to do is we're going to give that mass in atomic mass units, because again, that would be the simplest way for us to do it. So what does a single calcium atom have a mass of? Well, we go to the periodic table, and did I say calcium? I meant carbon. A single carbon atom have a mass of. We go to the periodic table, and it has 12.01 beneath it, right? So we're going to say, we don't have 1, right? We have 12.01 calcium atoms. So if I want to find the atomic mass of C6H12O6, I'm going to say, well, I've got 6 calcium atoms that have a mass of 12.01 AMU, right? So 6 times 12.01, that 01, I don't like the way that looks. Let me put my 1, there we go, AMU. All right, but remember, mass is additive. So I can just add up the mass of each of the individual atoms in there. I've got 12 hydrogen atoms, and looking at the periodic table, hydrogen has a mass of 1.01. So we're going to do 12 times 1.01 AMU. And then finally, we're looking at oxygen. Oxygen has an atomic mass of 16 AMU. So we're going to say we've got 6 oxygens that have an atomic mass of 16 AMU. Whoops. All right, so we do the math with that. And when we do it, we get that the mass of a single glucose molecule, C6H12O6, is going to be 180.18 AMU. So I'll just write that out over here, 180.18 AMU. All right, that's the answer to our first question. That's the atomic mass of this molecule. Now, the second part of the question says, what is the mass of a sample of glucose if it contains 6.02 times 10 to the 23 molecules? Now, when you hear that number, you should immediately go, that's familiar. I just learned that. That's what 1 mole is. So what they're actually asking us with the second half of the question is, what is the mass of a sample of glucose if it contains 1 mole of molecules? All right, so now at this point, it's important that we remember what we learned just a minute ago about these values on the periodic table. Remember, we were looking at calcium. Calcium's cut off. We can't see it down here. But what was true of calcium is also true of all these other atoms. In other words, let's look at carbon for a second, all right? Think about carbon. Carbon has an atomic mass of 12.01. Well, what that number, we said that number has 2 meanings, the number beneath it, right? So the other meaning is that if I have 1 mole of carbon atoms, and I'm going to abbreviate mole just MOL. I know that I'm only saving myself 1 letter, but when you write it over and over again, that 1 letter matters. All right, so if you see MOL, I mean mole. All right, so 1 mole of carbon is equal to this number here, but in grams, right? So 1 mole of carbon atoms is equal to 12.01 grams of carbon, okay? Similarly, if I had 1 mole of oxygen atoms, right? Then 1 mole of oxygen atoms would be equal to 16.00 grams of oxygen atoms, all right? So because that's true for each of these elements that are on the periodic table, now that we found the atomic mass in AMU of C6H12O6, that means that the mass of 1 mole of C6H12O6 is that value, but in grams, right? So 1 mole of C6H12O6 is equal to 180.18 grams. All right, that's the answer to the second half of the question. What is the mass of a sample of glucose if it contains 6.02 times 10 to the 23 molecules? Or, in other words, a mole of those molecules, it's 180.18 grams. Okay, well, the best way to get familiar with this, to get comfortable with this, is to just do more problems. So let's do a couple of other examples, example 7.2 and 7.3. I want to run through those before we cut off this video. But what I want to introduce a term, and that term is molar mass. Okay, so when we talk about the atomic mass of a molecule or an atom, we're talking about the value in AMU, all right, of a single molecule or atom. But when we're talking about the molar mass, we're talking about the mass in grams of 1 mole of that molecule or atom. So the molar mass and the atomic mass are closely related, right? This is the atomic mass of 1 glucose molecule, but then the molar mass is this value right here, because it's the mass of 1 mole of glucose molecules, okay? So make sure you know that. Make sure you know the distinction between that if I say atomic mass versus molar mass. All right, so let's move on to example 7.2. Example 7.2 says a student measures out 15.6 grams of magnesium chloride. So we have 15.6 grams of magnesium chloride. And I'm going to write that out. But we need to know what the chemical formula is for magnesium chloride. You have the knowledge to do that, whether you recognize it or not. You've learned that in a previous chapter. All right. So we have that many grams of that stuff. How many moles does he have? So that first question is A, how many moles? And then B, how many molecules? All right, if he has 15.6 grams. All right, well, just like when you see a problem like this, when you're trying to convert from grams to moles, this is eventually just going to become second nature to you. You're going to go, I need to find the atomic mass of whatever that is, all right? But in order to find the atomic mass, you need to know the chemical formula. In other words, I need to know How many magnesium atoms are we talking about? And how many chlorine atoms are we talking about in a single molecule? So in order to do that, based on the name, the first thing you need to know is, am I dealing with an ionic compound or am I dealing with a covalent compound? Now remember, the rule is we know it's ionic if it has what in it? I'm listening. Oh, I can't hear you. Someone said metal. You're absolutely right. Great job. I know that was really silly. But if you said metal, if you thought metal in your mind, excellent, right? Because that's how we know it's an ionic compound. Well, are either of these metals, magnesium or chlorine? Yes, magnesium is, right? We go to our periodic table, magnesium appears, and let's see if the periodic table's, oh, it's still there, cool. So magnesium is down here, right? It's over here with the color that matches the standard metals. And so since magnesium is a metal, then yes, it is, oh my goodness, I don't know what just happened. Since magnesium is a metal, then we know we're dealing with an ionic compound, right? So that means we're going to have to use swap and drop to figure out what the chemical formula is for this guy, all right? So that's what we're going to do. Let's see, are we writing again? Yes, that works. Excellent. And let's move this up though. Okay, sorry. All right. Looks like we're just going to have to leave it there. It's my whiteboard is misbehaving, but that's okay. We'll be all right. All right, so let's go ahead and work that problem out. 15.6 grams. We'll do the magnesium chloride formula up here. We've got Mg, right? And we've got Cl. And remember what we do to figure out what the chemical formula is for this. We figure out what the charge is. It's ionic, so these are ions we're dealing with. What would the charge be on the magnesium ion? It's the cation, so it wants to give electrons away to become positive. Well, it's in column 2A. We saw when we looked at the picture of the periodic table just a second ago. And since it's in column 2A, it's going to have a charge of 2+, right? Because it gives 2 electrons away. Chlorine, however, if you look at the periodic table, is in column 7A. So it wants to gain 1 electron. And if it gains that 1 electron, it's going to have a charge of 1 negative, right? So swap and drop says, swap the numbers and drop the plus and minus and drop those numbers down. And so when you do that, you get MgCl2. That's our formula. That's our chemical formula for magnesium chloride, right? Now, what is the atomic mass of a single magnesium chloride atom? Well, again, we go to the periodic table. And when we do that, we look at Mg. Mg has an atomic mass of 24.31. And we've only got 1 Mg, so it's 1 times 24.31 AMU, right? And then that's plus, we have 2 chlorine atoms, and we look at chlorine in the periodic table, and chlorine has an atomic mass of 35.45 AMU, right? And we add that together, and we get a value of 95.21 AMU. Now, what that means is, remember, once we find the atomic mass of the molecule, it means that 1 mole of this molecule is thus equal to 95.21 grams of MgCl2, okay? That is, the reason I'm saying is equal to is because that is now a conversion relationship we can use to convert between grams and moles, all right? So for magnesium chloride, this relationship is always true. And if we're dealing with that substance, we can use this relationship to convert between moles and grams, all right? So the first question, it says, if we've got 15.6 grams of magnesium chloride, how many moles of magnesium chloride do we have? And so to solve question A, we're going to say we start with 15.6 grams of magnesium chloride, right? But we want to convert that to moles of magnesium chloride. So we're going to use this conversion relationship right here. Just like if we wanted to go from inches to feet, we would say, I know that 12 inches is equal to 1 foot. And so I'm going to create a unit multiplier based on that conversion relationship. The conversion relationship here is going to be, we're going to put moles on top because that's what we're wanting to convert to. 1 mole of MgCl2, right? The top part, I mean the left half of this relationship is divided by 95.21 grams of MgCl2. Now, I'm going to encourage you to always put the substance on there. And the reason why is because 1 mole is not always equal to 95.21 grams. That's only true in the case of magnesium chloride. If we were looking at water, for example, 1 mole of water would not equal 95.21 grams, okay? So I'm going to encourage you to put the substance on the end of that so that it's clear. And the reason that matters is because in future problems, we're going to have more than one substance as we're doing these conversion relationships, and we need to make sure that we know which substance we're dealing with, okay? So we put grams on the bottom because we want that unit to cancel out. Grams of magnesium chloride cancel out there. And when you do the multiplication and division, right, in other words, taking this, multiplying it times 1, dividing it by 95.21, the value you end up getting is 0.164 moles of magnesium chloride. All right, that's how many moles of magnesium chloride we have. That's the answer to part A of this question. Now, what about part B? Well, we have to remember that 1 mole, we're using a second conversion relationship now, and that conversion relationship is that 1 mole of anything is equal to 6.02 times 10 to the 23, right? So there's our second conversion relationship we're going to need for this problem. And so we're going to take 0.164 moles of MgCl2, and we're going to multiply that by, we're going to put our number of molecules on the top, 6.02 times 10 to the 23. Whoops, wrong number. Molecules, and I'm going to abbreviate that like that, divided by 1 mole. That's what 1 mole is equal to. So here, our mole units are canceling out. And when we do that multiplication, we get a value of, let's see, they've already done it in the book for me, 9.87 times 10 to the 22nd power. We get that many molecules of MgCl2, right? Okay, now notice I didn't write MgCl2 here. I didn't write MgCl2 here. Why didn't I? The reason why is because these values are not unique to MgCl2, right? 1 mole is, in fact, always equal to 6.02 times 10 to the 23, no matter what it is. That was not true with this, right? 1 mole is not necessarily equal to that many grams. All right, so that's our two answers. Now, if you're confused about this, right, I'm going to encourage you to pause the video, maybe rewind it, go back and watch me walk through it again, or look at it in the book. Look at his explanation in the book, right? Because it is super critical that you get this down. This is so important. We're going to use this over and over and over again. So it really matters that you understand this, all right? This is not something to think, I'll eventually get it, no big deal. No, you need to get it. All right, let's do one more example. If you are confused, we'll do one more example. And then again, if you're still confused after this, I highly encourage you to rewind the video, watch it again, or go to the book and read his explanation and see if it makes more sense, okay? So our last problem that we want to do in this section is a chemical calculation indicates that a reaction should produce 12.119 moles 12.119 moles of nitrogen gas. Now, nitrogen is one of our homonuclear diatomics, and so nitrogen gas is N2, not just N, right? So it's important that we remember that. And the question is, how many grams? If we've got that many moles, how many grams do we have? Now again, this is a conversion problem, and we have to know how to convert from moles of nitrogen to grams of nitrogen, right? So how do we do that? How do we go from moles to grams? Well, we do that by using our relationship between moles and grams for nitrogen that we learned from the atomic mass of nitrogen in the periodic table. All right, so we go to the periodic table and we look up nitrogen, and we've got 2 nitrogen atoms, but we see that nitrogen has an atomic mass of 14.01 AMU, right? And so we multiply that together and we get 28.02 AMU. That's the atomic mass of a nitrogen molecule. But we need to remember that that means once we find the atomic mass, right, just to use those terms again to make sure you don't forget the difference in those terms. If I find the atomic mass, then I know what the molar mass is, which means that 1 mole of N2 is equal to 28.02 grams, right? Same number in the front. It's just one has a unit of AMUs, the other one has a unit of grams. And again, this value here is what we call, this value in grams is what we call the molar mass, because that's the mass of 1 mole of that molecule or atom, depending on what you're looking at, right? In our case, it's nitrogen gas, so it's a nitrogen molecule since it's 2 atoms bound together. All right, so now we know our conversion relationship. This is our conversion relationship right here. They told us how many moles we had, 12.119 moles of N2. And I can use my conversion relationship, right, to convert from moles to grams. I want to go 2 grams, so I'm going to write grams on top, 28.02 grams of N2 is equal to 1 mole of N2. I put that on the bottom, all right? My moles of N2 cancel out. I do the math with that, and I get 339.6 grams of N2. That is the mass in grams of 12.119 moles of N2. All right. Now, one thing I want to show you real quick, because as these conversions get more complicated, we're sometimes going to be doing a unit conversion like this one right here, but then right after that, we're going to multiply another unit conversion and we're going to multiply another one. So I'm going to start, I'm going to introduce this idea where instead of doing times right here, I'm just going to write this as, it's going to kind of look like a grid or like a table. So I'm going to write it like this. All right. So when you see me write it this way, it just means I'm multiplying, right? This bar right here just means multiplication. So we're taking this value here, we're multiplying it by this top number. Whatever's on the bottom, we're dividing by that, right? So with unit conversions, these long drawn-out unit conversions, you're going to see that over and over. Another, like for example, if we're going from, let's say we want to know how many hours are in, I don't know, 596 seconds, right? If I wanted to figure that out, 596 seconds, how many hours is that? I could say, well, first, I know that there is 1 minute in 60 seconds, right? And then I could say there is 1 hour in 60 minutes, right? And so then I would see seconds cancels out, minutes cancels out, and basically this is the math I have to do in order to figure out how many seconds are in 596, how many hours are in 596 seconds, right? And so that's the multiplication and the division that I would do to figure that out. So we're going to have problems eventually that look more like this in chemistry. And so the table or grid way of laying it out just helps keep us a little more organized, helps us see things a little bit easier than having the little multiplication sign in there. So you're going to see me start kind of converting to that method of writing down these conversions. All right. But notice what we did. In 7.3, we went from moles to grams, right? And in 7.2, they gave us grams, and we went and we figured out the number of moles, right? But in both cases, we used the conversion relationship that we figured out by going to the periodic table and calculating the atomic mass of the substance, and knowing the atomic mass gave us the ability to know the molar mass, which is what actually allows us to know this relationship here, okay? So this idea of going to the periodic table, figuring out the atomic masses, and then knowing the molar mass, again, that's a concept we're going to use for the rest of the year. This is going to keep coming up. So you're going to have some practice, some comprehension check problems to practice this. Super critical though, if you're confused about anything, let me know so I can get those questions answered early. All right. I know this video is a little longer than some of our other videos have been, but it's really, really important that you get this. So again, reach out if you have questions. All right.